Hello, Dr. Jares here. This video is the first video among a series of videos where we will be creating 2D games in CPP. For that, I will be using OpenFrameworks library, and as a text editor, I will be using Sublime Text. The first step is to know how to install this OpenFrameworks library in your computer. Open up Safari, go to openframeworks.cc download, then go down here. There you can see the OpenFrameworks library for different operating systems. Choose your favorite operating system. I have downloaded OS X version for that. And after downloading, you will see these directories within OpenFrameworks main directory. From there, you can select project generator. In this case, this is OS X, where you can specify your project name and project path. YouTube project, T-Rex game, and click generate. It will generate everything automatically. Then press close, and go to the OpenFrameworks main directory and select apps, my apps. There you can see your project being generated here. Just drag and drop it into a text editor and open up the directory, and you can see that there are 3 main directories. We are not interested in this directory. This one is generated for Xcode development, and this bin directory will contain binary files, and this data directory should contain the related data files like the sound files, the image files, and etc. And this source directory, that you can see that there are 3 files. One is main.cpp, the other one is OFAP CPP implementation and its corresponding interfaces. We will be focusing on these 2 files, ofap.cpp and ofap.h. As our first game project, I will be developing the T-Rex game that we can see in a Chrome browser when network error happens. So let me get rid of the functions that we will not be using for now. Okay, and from the CPP file as well. Okay, we are ready to go. In this part 1 video, we will create that dinosaur body that can just jump when we press a button on our computer keyboard. At the very beginning of time, you may not be able to understand what I'm doing, but at the very end, you can relate everything and understand why I wrote some code. So let's start. Because we are going to create a jumping dinosaur, we need to define some classes for that. The first one will be a body class, so let's define that. Class body. So this class will act as the body of that dinosaur. So that body needs some location, velocity, and acceleration vectors. So let's define that. Now let's define some public functions. And a constructor. Okay, our body also needs a mass as well. Let's define a unit mass. Set the location to some reset position. Dot set. We may need a velocity limiter variable. So let's define that as well. Okay, that's fine. Now let's define the functions. A function to set the location of that object. To get the current location. Another function to set the current velocity. And to get current velocity. Another function to set current acceleration. And to get that. Now let's define some functions um, to do some vector operations on the vectors that we have already defined, like location, velocity, acceleration. everything is K. Okay. The next class that I'm going to define is a material class. This class is required because we need to draw something on the screen. Even if we have defined the body class, that only contains the physical properties of that object. So to define the visual properties of that Dino object, we need another class called material. So let's define that. The sprite sheet that we will be using for this project can be in data. So here is the sprite sheet that we will be using. A function that's needed to load this sprite sheet. And another one to extract the image from that spreadsheet. Okay, now our second class is okay. Now we will define our dinosaur itself as a class. That will have a material. That will have a body. And to display that. Okay, we need to pass some parameters to this display function because the dinosaur may have different modes at different time. It may be idle sometimes or dead sometimes. It may be running or ducking. So we need to specify these values to the display function for proper displaying of current state of that dinosaur. For that, let's define an enum. Dino running, dino duck, dino idle, dino dead. Dino mods G. Okay. Now our dino class is ready. Everything should go above our main class. And let's create a dinosaur in our main class. Okay, the classes are ready. Now let's define the member functions within each class. First of all, let's define the body class members. Let's copy. Okay, first of all, set location. Okay, that's all. Then get location. Okay, then set velocity. Then get velocity. Now set acceleration. Then get acceleration. Then add velocity. And acceleration. Then apply force. So here the point is we need to get acceleration from force, that is force by mass. So I'm going to use add acceleration and will get force by mass. Then apply acceleration. Then update location. Then apply physics. So here what happens is, first of all, we applied some acceleration to our current velocity. So just after applying acceleration to our current velocity, the acceleration must be reset, because we will be calling this in some loop. So if we do not reset this acceleration, every time some value, some old acceleration value will be added to velocity, so the speed will increase exponentially. That's not what we wanted. So after applying an acceleration, immediately we should be resetting that acceleration value, so that the velocity will get some instant growth, and that instant growth will be applied to our location at every time. So first step is to apply acceleration, and then there is another condition, because we need to limit the velocity beyond some value. So if the acceleration exceeds that velocity limit, we need to cut that velocity towards our desired velocity limit, and after that we will update location. Update location means add velocity to current location. That's how the object will move. Then body functions are ready. Now let's define material member functions. Okay, first is to load a sprite sheet. We will be using some OpenFrameworks function for that. Okay, loading is okay. The next step is to draw a subsection of that sprite sheet. We will be using a draw subsection function from OpenFrameworks library. Now let's define our Dino member function. Okay, in Dino display function we will get different modes, so we need to write a switch case to handle each mode. Now we need to keep track of the Dino's legs. So if active leg is left leg, then we need to draw left leg dino. So material, draw material. Firstly we need the x and y locations. So body get location dot x. Y. I know the values, so I will be typing in them. And also we need to change the leg. If um, we need to change the left leg to right leg as well, so we need to do that. 0.3 can be set to the leg trigger second, and we need a frame counter. And frame rate. So that's fine. Then if leg in the front if leg frame counter is greater than or equal to frame rate times leg trigger second, then we should reset the leg frame counter and should set the active leg to the right one. And vice versa. Let's do the same for dyno duck as well. Where these values only changes. And let's and finally we need to increment this leg frame counter. Okay, now let's compile this. Okay, fine, it's error free. So every member functions have been defined. Now we need to use these functions. The start point of the dinosaur should be set. So the dinosaur will sit at the x location 100 and y location 100 of our display plane. So let's set that to our dinosaur body. Dino body. Then set location. Start point is being set. And also we need to draw our dino. Mm, 255. So we should display the dino. So dino dot display. Okay, where is that display function? Some mod need to be set. Where is the mods? Dino running. Okay. Right. Then run it. Okay, now our dino is running. The next step is to make that dino jump when we press a key. So first of all, we need to define a gravity for our game. This is a gravity force vector which will always act downwards. Okay, that's not a good idea. Maybe 0, 1 may help us. Now we need to define a floor for our dino. So maybe define floor y. Then maybe 300. We don't need to apply that gravity if the dino is on the floor. So we need to write a if case for that. If dino's body get its current location, and if its y component is lower than floor, then only apply gravity. We need to check whether the dinosaur is on the floor. If it's above the floor, we need to apply the gravity. Otherwise, we need to reset its velocity y component. So that's what we are going to do. Get current velocity. Then get only y component from that velocity. Now let's add this to our current velocity. Then now let's reset its location to that 300 y component location. So we need another vector. Otherwise we can modify this. Current x component of location and floor location. Then set that to current location. Now everything being set, we need to apply the physics to Dino. Okay, now we should see the gravity being applied to our dino. Okay, the gravity is being applied to the dino and it's being locked at the floor at 300 y position. Okay, now let's make our dino jump. For that, we need to use this function keep rest. And if the dino is on the floor, we need to apply a jump force upward. So we need to check whether the dyno is on the floor. Dyno's body and get its current locations Y component. If it's at the floor, then create a jump force. Maybe 0 minus 30 will help. And dyno's body apply force, this jump force. Okay, now let's see what happens. Okay, our dyno is jumping when I press any key on our keyboard. Wow. If I keep pressing the keys, only the dyno jumps if it hits the floor. If we haven't included that floor check, it will be jumping from any point when we press a button on our keyboard. That's not needed. That's why we have added an if check whether the dyno is on the floor. Now let's add some other parameters to uh, make this even better, because as we see in Chrome, at the very beginning dyno is not running. It's at its rest position. Whenever we press a key on keyboard, then only it just starts running. So we need to add that as well. So we need a um, game class for that to manage everything in that game, including the score that we will be using later. So we need to create that class. We need a constructor to reset everything. Okay, here we go. Now let's move back to the source file, and let's see. We need a game global variable. Okay. Then we need to decide whether the dyno is running or staying idle. So I'm going to add a check here. should work. Okay, that's fine. It works. At the beginning, it's at idle state. Whenever we press a button, it starts to run. Okay, that's for today. Thanks for watching, guys. See you in the next video.